Okay, last intro of this section says Emily, a groupie who was getting $30 per lap and had $20 in donations, wanted to make between $200 and $350 during the walkathon. So question 1 says how many laps would she have to walk in order to reach this goal, to be between that goal? Well, let's go ahead and look at this. She has $30 per lap plus her $20 in donations. She wants that to be greater than or equal to $200. She also wants her $30 per lap plus her $20 in donations to be less than or equal to $350. So we have actually 2 equations here that we're going to have to solve for. So if we subtract her $20 in donations, we end up with 30 greater than or equal to the 1800. Divide the $30 per lap. So it looks like she's going to have to do more than 6 laps. But then again, she doesn't really want to go over 350. So we're going to subtract the 200 over on this one. We have 30 laps has to be less than or equal to 330. Okay, dividing that 30 over, she wants her laps to be less than or equal to 11. Okay, so how many laps would she have to walk? We're going to say between, because she said between 6 and 11 laps. Okay, what we just did was we solved a compound inequality. So if we look at our laps, we want our laps to be greater than or equal to 6. We also want it to be less than or equal to 11. So my laps want to be less than or equal to 11, but my laps want to be greater than or equal to 6. That's how we write a compound inequality. We are saying that it's between these 2 values. Notice how my inequality signs are pointing. It looks like they're both pointing to the left, but when we read this, this is laps are greater than or equal to 6 and less than or equal to 11. So that is called a compound inequality that deals with the and. Now let's go ahead and look at a different kind. The school was letting the groupies borrow the track, but stated in order to keep it safe, the students would have to stop walking if the temperature dropped below 35 degrees or was hotter than 95 degrees. So if the temperature at the start of the walkathon was 60 degrees, state the drop and rise in temperature that would force them to cancel the walkathon. Okay, so if we look at this, we have 60 degrees plus what temperature is going to make it less than 35 degrees. And 60 degrees plus what temperature is going to make it greater than 95 degrees. Well, looking at this first one, if you remember earlier, we subtracted that 60 over, and we knew that we would have to have a drop of 25. And I'm not going to put that negative in here because in this real world situation, we realized that we would have a drop of negative 25. Well, actually, I'm going to put a negative on there because it is a drop. Then we're going to subtract the 60 over here and realize that we would have to have a rise of 35. Okay, so state the drop and rise in temperature. It would have to drop 25 degrees or rise 35 degrees. So notice here we said or, which means that our T has to be less than negative 25 because that's a drop, or our temperature has to rise 35. So here's our other compound inequality. Here we said and, our laps were greater than or equal to 6 and less than or equal to 11. Here we say or. Our temperature has to be a drop of less than negative 25 or an increase of 35. So 2 different types of compound inequalities, an and statement and an or statement. And we are going to look at both of them in this section. So go ahead and get out the notes and vocab for this section. Okay, our objectives have been the same for this whole chapter, knowing that we are solving linear inequalities, we're identifying and graphing, we're solving those real world problems, and then writing those linear inequalities. They do a good job of explaining what these look like for graphs, looking at the intersection. So I'm going to read this. When considered together, two inequalities, such as h is greater than 52 and h is less than 72, form what's called a compound inequality. A compound inequality containing and is only true if both inequalities are true. Its graph is where the graphs of the two inequalities overlap, and this is called the intersection of the two graphs. This is dealing with that and. When we had our laps in the middle, it was greater than our 6 and less than our 11. So this is an intersection because look at this. We're going to look at their example. They have greater than or equal to 3. They have less than 7. Notice where they intersect. They intersect between 3 and 7. So this is the solution then to our inequality because all of those values are true for both of those inequalities. Okay, so again, the statement, look at how you read this. X is greater than or equal to 3 and less than 7. Okay, so please, when you're reading this, do try to read it like that so we understand that this isn't 3 is less than or equal to x. We always look at x and then work out. So let's go ahead and see how we graph this inequality. This looks kind of weird because we have two inequalities now. Well, remember we're dealing with a compound inequality. So when we have that x in the middle, we know this is going to be an and statement. So I'm going to rewrite it over here, knowing that this says x minus 3 is greater than or equal to negative 2 or less than 4. So since this is a compound inequality, we have to understand that every operation that we are undoing, we have to undo from both sides of this equation. So I am trying to get x by itself, which means I have to add a 3. I have to undo the 3 from the x part, from the x section. I have to add a 3 to the right. I have to add a 3 to the left. So this turns out to be a 1. I do get x by itself, and I have that is less than 7. So again, let's read this. This is saying that x is greater than or equal to 1 and less than 7. How do we graph that? Well, we know we're dealing with 1, so I'm going to start with maybe a negative 2, 0, 2, 4, 6, and 8. I realize that this is greater than or equal to, so I'm going to fill in my point at 1, and I know that it's less than 7. I'm going to go here and have an open point, and I know it's all solutions in between. So one check, when we know that we're dealing with an and solution, we should have our smaller number on the left, our bigger number on the right, and both of our signs are pointing to the left. That doesn't mean both of them mean less than, but they are pointing to the left. So a nice little check to make sure that we are correct. And then when we graph it, our graph should be true as well. All right, let's go ahead and look at 1A. The way it's written is kind of weird, so I'm going to do 1A with you, and then you can do 1B on your own. They have it written in two different pieces. So we're going to go ahead and solve both pieces, and then we are going to combine them together. So rewriting them, I'm going to go ahead and solve both of these. So I'm going to add 3 to both sides. I have y is greater than or equal to negative 8. I'm going to solve both sides. So add that 3, and I have y is less than or equal to a negative 5. Okay, remember how I said our smaller number is going to be on the left. So we are going to write this as negative 8. I know my y is in the middle, and I know my negative 5 is over here. This is saying y is greater than or equal to negative 8. So y is greater than or equal to negative 8. This also says y is less than or equal to negative 5. So y is less than or equal to negative 5. Does that say the same thing as here? Yes, it does. So here is my and statement. Now I'm going to go ahead and graph this. So I'm going to start with the negative 10, -8, -6, -4, -2, and 0. Knowing that at -8 I have a closed circle and at -5, and I know it's every value in between. So understanding that and, go ahead and solve for both of them and then combine them together. Smaller number on the left, bigger number on the right. Both of your inequalities should be pointing to the left. Okay. Otherwise, don't split up 1b. Go ahead and solve it like we did with example 1. Okay, keep in mind that compound inequalities we are going to subtract or undo from both sides. So I subtracted the 7 from both sides. Also, really making sure that when you graph this, we understand this is greater than or equal to, so that's a closed circle. This one is just less than, so that's an open circle, and everything in between that is true. So a lot of little things we have to keep in mind when we're solving these inequalities. Okay, looking at this one now, we're looking at containing that or, which was the second part of our introduction. It says another type of compound inequality contains the word or. Compound inequality containing or is true if at least one of the inequalities is true. Its graph is the union of the graphs of the two inequalities. So notice that this is greater than 2. This is less than or equal to -1. So an or statement, our arrows are pointing opposite directions. Okay. When solving problems involving inequalities, within is meant to be inclusive. So use that greater than or equal to, less than or equal to. Between is meant to be exclusive. So this is just a good translation type of thing that we're going to look at when we deal with real world examples, which is what we're dealing with. So it says the human ear can only detect sounds between the frequencies of 20 hertz and 20,000 hertz. Write and graph a compound inequality that describes the frequencies of sounds that humans cannot hear. Okay, so it says between those frequencies. So in this situation, that was supposed to just be a less than. Well, we cannot hear that 20 hertz. So we know that our hertz that we cannot hear are less than or equal to 20. Okay, or the hertz are greater than or equal to 20,000, because again, we're looking at what we cannot hear. Since they said between, we know that we are going to use the equal sign because we're looking for what we cannot. Okay, now the fun part of how to graph this. It looks like we're probably going to have to go by 1,000 on each one of these. So there's 1,000, 2, 3, 4, 5, 6, 7, 8, 9, 10,000, and then 10,000 and 11, 12, 13, 14, 15, 16, 17, 18, 19, and here's our 20,000. So how are we going to do this? It's less than or equal to 20, which is probably going to be about here, less than, and again, greater than or equal to that 20,000. So anytime we see that or statement, we understand that our arrows are pointing opposite directions. Okay, so keep that in mind for guided practice number 2. Go ahead and give it a shot. Okay, tricky type of question because the company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11 centimeters tall. So it has to be between those two values. Okay, so this is actually an and statement. It has to be greater than or equal to 11.2, less than or equal to 11.4. Okay, so understanding what it is that we're looking for. Graphing this is kind of tricky, so I went by tenths in order to be able to see that a little bit better. Okay, now we're going to go ahead and solve and graph what's called a union. Union and or are synonymous. And understanding that when we graph this, we are technically solving two inequalities, and then we're going to graph them on the same plane. So when we look at this, we have 2m, negative 2m plus 7, less than or equal to 13. We have 5m plus 12 is greater than 37. Now we just go through all of our steps. We're going to add or subtract first. Then we're going to multiply or divide, realizing we have to remember our inequality rules. I just divided by a negative, which means I'm going to say greater than or equal to a negative 3. Now I'm moving on. I'm going to subtract a 12 from both sides. So I have 5m is greater than 25. And then I'm going to divide by that 5. M is greater than 5. Okay, and we realize that this is an or statement, so we're going to put or in the middle. Well, this is kind of different because both of our graphs are going the same way. So I'm going to go ahead and graph them both and see what happens. I'm going to start here with maybe negative 6, negative 2. Okay, so I'm going to graph my greater than or equal to negative 3, which is right here. And it goes a little bit further than that. I'm going to make my line way down here. Then I'm going to graph my greater than 5, which is right here. Well, look at that. This is an or statement. So that means that all of these values will work. So that greater than 5 kind of gets blended in because it's actually part of our greater than negative 3. So the solution to this problem is actually just m is greater than or equal to negative 3. That is going to happen every now and then. Most of the time, though, you are going to have ors that go separate ways. So if this does happen, do make sure you go back and make sure your math is correct. Otherwise, graph them both, step aside, and realize what does that mean. This greater than 5 is a solution here, so we're not even going to use it. We know that m is going to be greater than or equal to a negative 3. Okay, go ahead and try guided practice 3. Okay, 3a is a pretty straightforward or compound inequality that I do like, and these again are going to be 90% of the type of graphs that you are going to see with or statements. We have a is less than 3 or a is greater than 4. So looking at how we graph this, you're going to see that your graphs are going to be going opposite directions. Okay, 3b, they just give us the first solution already, which is kind of nice. X is less than or equal to 9. Or then we're going to have to solve this. We end up with x is less than 2. Again, we have them going the same way, so go ahead and figure out what this means. X is less than or equal to 9, which when we go up here and graph that is right here. Or x is less than 2, which we realize is blended into our solution. So what is our solution? X is less than or equal to 9. And we don't even need this piece up here because we understand that that solution is satisfied when we graphed our x is less than 9. Okay, so really just once you get your solution, understand what it means. Understand what is true for each one of those. Okay, biggest thing is realizing that or statements are going to be pointing away from each other and statements will go towards each other. Okay, go ahead and give the assignment for this section a try.